the title, and we will spend some minimum 4-5 lectures on it. The topic is, they are all same thing: shock spectrum, response spectrum, transient excitation. This is the heading, but slightly complicated. So let me begin. What do we mean by shocks? What do we mean by shock? Shock is nothing but excitation. Shock is nothing but excitation, but there is a difference between transient excitation and shock excitation. Transient excitation is excitation that doesn't last for a long time. Shock is also an excitation that doesn't last for a long time, but normally shock, the time period, the duration of the shock is less than natural time period of the system. So you just read it. You don't have to write it, but read it. How do we define shock? Just read it. As I am saying, you don't have to write it. And how do we define response spectrum? I will keep this particular page for 3-4 minutes so that you can read it 5 times and try to understand what I am saying. पूरा पेज को नीचे ला सकते हैं क्या? लेट मी सी. हाँ, पूरा पेज को नीचे लाता हूँ so that you can have a look of the whole page. Correct. So read this again and again for 2-3 minutes. If you have not understood, after 2-3 minutes you can ask me a question, but read it carefully. Because the shock and response spectrum, they are different. You need not write down, but you can read it carefully. So what is the basic difference? If I ask you, we have 2 types of excitation: periodic and non-periodic. So today's discussion is the beginning of system under non-periodic. Generally we call it aperiodic or transient excitation. Non-periodic excitation generally doesn't last for a long time, so we also call them transient excitation. Now, what is the basic, if you read it, and if I ask you now, in vibration, our approach under a periodic excitation and an approach under transient excitation or shock excitation, there is a fundamental difference. What is that fundamental difference? After reading this PPT, you have to answer this question. So you have to answer my question. If you read this line, tell me how our approach for shock excitation is going to be different from whatever we have done for harmonic excitation or periodic excitation.
Earlier, we never compared the natural time period with.
No, our excitation does not have any time period. Let me make it clear. Now our excitation does not have any time period because it is not periodic.
So here we consider only the maximum value of the response because like that's our ultimate goal to account for that.
In periodic, don't we focus on maximum value of response?
So we do, but we also take care of like, sometimes there's Courier and also.
Now, what is the difference? I mean, don't you mean to say that in periodic excitation, we are not concerned how much is the maximum response? We are. There also we are.
In periodic, we have taken response as steady state. Here we have to take in transient.
So the concept of steady state is applicable for periodic. See, the basic difference is simple. Basic difference is that in periodic excitation, if we can find out the first maxima, then we know that this maximum value will occur again and again, but its amplitude will remain same. In transient excitation, we don't know. So we have to simulate it for sufficiently long time. Sufficiently long time. So when you do it, you will come to know. In periodic excitation, there is only a single phase. That is, in periodic excitation, always it remains forced. That means the excitation remains throughout. It doesn't come and vanish. In transient, excitation come and then go away. So in transient, there will be two phases. One is the duration when the force is present. After that, the duration when the force is no more present. So in transient excitation, we will have two phases or two durations. In the first duration, excitation is present. And in the second duration, excitation is gone. We have to study both. We have to study both because the maximum vibration may not occur during the presence of the force. It may occur after the force has gone away. We don't know. So we have to study both the durations or both the phases. Finally, in transient excitation, our objective is what is going to be the maximum vibration. But let us make it clear. In steady state periodic excitation, the maximum vibration comes again and again. Whereas in transient excitation, maximum vibration will come only once. It will not come again and again. What does it mean? What does it mean? As an engineer, my last sentence is very, very important. Why? Let me repeat again. In periodic excitation, whatever is the maximum vibration, it occurs again and again. In transient excitation, whatever may be the maximum vibration, it occurs only once. It never repeats itself. It occurs only once because my excitation is transient. How does it make a difference in the mind of an engineer? It's a very important difference to an engineer. Why?